Some of the ShepNotes slides provide a lot of information and insight into complicated and confusing issues. At the end of each slide, a chime and a small picture of my friend Becca are provided to indicate a good place to pause the video when you want more time to understand the material on the slide before moving on. Batch commands. A useful feature of the ti-nspire, TI-84, TI-89, and other TI calculators is the ability to place parameters and functions in lists so that several calculations can be performed with a single command. The series of individual functions, the sine of 30 degrees, the sine of 45 degrees, and the sine of 60 degrees, can be placed in a list enclosed in curly braces and separated by commas, and the calculator will display the results in a convenient output list as shown in the following example. As shown, the sine of 30 degrees is 0.5, the sine of 45 degrees is 0.707, and the sine of 60 degrees is 0.866. This edition of ShepNotes will show several examples of batch commands and their variations. When I use the phrase batch commands, I am referring to any calculator command or operation that has been modified by replacing one or more of its input values with a list of values so that it can perform a batch of similar operations in a single command rather than performing each of these in the list with a separate command for each input value. Many but not all of the examples shown here will work on older and still useful calculators like the TI-84 and TI-89. Let's try out an example of using a simple batch command. Step 1. Assign a list of values to the variable a. In this case, the variable a will be assigned the values 1, 2, 3, 4, and 5. Step 2. Type a on the command line to display the list of values assigned to the variable a. Step 3. Type a to the second power on the command line to display the square of each of the values assigned to the variable a. Step 4. Type 10 times a on the command line to display the values assigned to a multiplied by 10. Now let's try a batch command on a user-defined function. Step 1. Set the user-defined function f of x equal to x cubed. Step 2. Use f of x to display the cubes of 8 different values by replacing x in f of x with a list of the 8 values. The function will return the cubes of each of these values in a convenient output list. Now let's try a batch command on a more interesting user-defined function. Step 1. Define the function f of x and y to equal x raised to the yth power. Step 2. By replacing x and y with the same list of numbers, f of x and y returns the results of these numbers raised to their own values. As shown in the output list, 2 raised to the second power is equal to 4, 3 raised to the third power is equal to 27, and 4 raised to the fourth power is equal to 256. When lists are used in a command, the calculator loops through each value in the list from the first item in each list to the next until the values in each position in the list have been used. The result is placed in the same position in the output list. Step 1. Define the function of xy equals x to the yth power. Using the first value in each list, the function of 2 to the second power equals 4. Next, using the second value in each list, 3 to the third power equals 27. And last, using the third value in each list, 4 to the fourth power equals 256. In this example, the user-defined function area returns the area of a rectangle when the length of its sides and top are given. When the area function is called with the side and top replaced with a list of the sides and a list of the tops for 6 rectangles, they can all be evaluated with a single command. As indicated in the output list, the area of a 5 by 5 rectangle is equal to 25. The area of a 12 by 4 rectangle is equal to 48. The area of a 15 by 3 rectangle is equal to 45. The area of an 18 by 8 rectangle is equal to 144. The area of a 25 by 2 rectangle is equal to 50. The area of a 30 by 10 rectangle is equal to 300. Let's look at some examples of using batch commands to evaluate built-in functions by replacing their parameters with a list of parameters, so that several of these calculations can be performed at once with one single command. Example 1. Replace the angle usually placed inside the parentheses of the sign of x with a list of 5 different angles, and the output list displays the sign of each of those angles. Example 2. Replace a value usually placed in parentheses for the function factor of x with a list of 6 different values, and the output list displays the factors for each of these values. The expand function displays the results of the product of 2 polynomials placed in parentheses. This function can be expanded, and the pun was intended, to display the products of 2 different sets of 2 polynomials by placing the sets in a list. The output list in the display shown above clearly shows that the quantity x plus 2 times the quantity x minus 3 equals x squared minus x minus 6, and the quantity x plus 5 times the quantity x plus 2 equals x squared plus 7x plus 10. The logarithm of a number is the exponent to which a fixed value called the base must be raised to produce that number. The log, or logarithm of 100 to the base 10 is 2 because 100 is 10 to the power of 2. When this function is entered as log to the base 10 of 100, it returns 2 since 10 raised to the second power does equal 100. By replacing the base 10 with a list of bases and the number 100 with a list of numbers, the function returns a list of the logs of numbers for the respective bases. When this batch command is executed, it reveals that the log of 16 to the base 2 is 4. This means that 2 to the fourth power is 16. The log of 64 to the base 8 is 2. This means 8 to the second power is 64. The log of 1000 to the base 10 is 3. This means 10 to the third power is 1000. The log of e to the fifth power is 5. Obviously, this means e to the fifth power is equal to e to the fifth power. Hi friends, this concludes the first ShepNotes presentation on batch commands. Watch for the next ShepNotes edition, which will show a few more examples of batch commands, including some applied to graphics.